Hey, welcome back to Math with Patrick. Today's June 24th, and we're solving problem number 175 from the Daily Epsilon calendar. And let's show why this expression here is equal to 24 today. So I see a number in here, and then we're going to evaluate it. That's 16 cubed. I see another number here where we're going to take that large number and then raise it to the power of 1/6. And then finally, we're going to apply the factorial function, which, just to show you an example, 5 factorial is just 5 times 4 times 3 times 2 times 1. A factorial, you just multiply all the numbers, all the whole numbers, down to 1. And actually, I'm going to amend my plan. I know I did say I'd find 16 cubed, but that does seem like a large number. And instead, I'm going to use an exponent rule here, where I'm going to claim that if I have a base to the power of one exponent and then another, I'm just allowed to multiply those exponents together. And I'll just show you an example to make sure that we're both on the same page that this does indeed work. Let's say I have a base of 2, and I'm raising it to the power of 3, and then the power of 2. Just the meaning of squaring a number is multiplying it by itself. And so we can expand our square by multiplying 2 cubed by itself. And then the meaning of cubing something is just multiplying it 3 times over. And so I have 3 2's over here and 3 2's over here. And ultimately, I have 6 2's, which is, I think, 64. But more importantly, at least for my example here, it's 2 to the power of 6. And one thing that you can see here is that 3 times 2 is 6. And we also can see we have two groups of 3. And that kind of tracks with the meaning of multiplication. So anytime you have stacked exponents like this, where you evaluate the one on the inside before the one on the outside, you can just multiply them together. So that's going to make the process considerably easier in finding this inside number. I could just call it 16 to the power of 3 times 1/6. That's going to be 16 to the power of 3/6, or 16 to the power of 1/2 after I reduce my fraction. And maybe you already know that the power of 1/2 is the same thing as a square root. I also want to kind of prove that or show that right now. So like the meaning of a square root is that when you multiply a square root by itself, you're going to get the number underneath the square root sign. That's just kind of by definition. With exponents, there's another exponent rule that I want to prove to you right here, where if we have the same base and we raise them to, maybe they're different powers, maybe they're the same power, but if you have the same base and you have some powers on it, you're totally allowed to add these exponents together. That's just because we have some amount of a's being multiplied here, and then they're being multiplied by another amount of a's, and essentially there's just b plus c amount of a's all being multiplied up. So it doesn't matter what these numbers are. You can use this rule and it works. So specifically, if I have x to the power of 1/2 times x to the power of 1/2, I can add those exponents together and I'll get x to the power of 1. And this shows that x to the power of 1/2 is the same thing as a square root. So with this knowledge, we can evaluate 16 to the power of 1/2 as just a square root of 16. I know that 4 times 4 is 16, and therefore, all of this inside stuff just evaluates to a 4. So to find 4 factorial, all we need to do is 4 times 3 times 2 times 1. This is a 12. 12 times 2 is 24, and that is today's date. So there we go. That's the answer. That's how I'd solve it. Maybe if you really wanted to, you could do 16 to the power of 3, but that's a pretty big number, and I'd rather not work with big numbers. So anyways, answer is 24. I'll see you tomorrow. Bye.